Hello, I'm Timon Sloane from the Open Networking Foundation, and today I'm pleased to welcome Telefonica to our ONF Spotlight on Broadband series. Telefonica has been working with ONF for quite some time. Telefonica has had early field trials of Chord and later of Siva and Volta, and is one of the operators leading the efforts looking at interesting use cases for edge cloud applications beyond simple connectivity. So today, Telefonica is going to share with us some of their interesting research and insights into what they believe is required to support cloud gaming at the edge cloud. So with that, I'd like to introduce Cesar and Xiao, who are both part of the global innovation team with Telefonica. Cesar?
Hello, everyone. Thanks for that introduction. As you were saying, yes, I'm part of Telefonica Global Innovation Team, working as a manager at Connectivity Innovation, specifically working nowadays around cloud gaming and how can we increase the experience and improve the experience from within our networks and our connectivity. Xiao, do you want to go ahead?
Yeah, thank you, Timon, for the introduction. I'm working with Cesar in this challenges we're facing. You know, as operator, we try to provide good cloud gaming experience to all customers, and we have been working hard together with ONF, try to see what kind of requirement should we push forward to provide this kind of new kind of service that require, you know, bandwidth, require a quality of service. And I strongly believe that cloud gaming is one of the best use cases for all the new network technology that we're building inside or outside of ONF.
Okay, thanks, Xiao. So let's go to the first slide, please. As you were mentioning, the challenge that we wanted to share today is very based on cloud gaming, because cloud gaming is one of those few services that we can find today, more or less a real one, which really demands for futuristic capabilities and futuristic specifications that our networks will need to provide in order to guarantee the experience. So we thought it was a great example to share with the community, and basically obviously wrapping everything up in the form of real networking specification challenges, which hopefully you guys can help us solve with SDN and without SDN, or we don't know. And that's one of the questions that we are here to solve. So if we talk about what cloud gaming is, just to provide the right context to everyone, well, it's really literally pushing all the capacity that you will normally have locally in your laptop, in your mobile phone, in your CPU or GPU equipment. It's basically pushing all of that into the cloud, which obviously has a big impact in our network, because suddenly a lot more traffic and a completely different type of traffic will be transported, and it's very, very, very sensitive to the final experience for the gamer. Xiao, can you move forward, please? So this is the the actual problem. If we were to look at the actual gamer today, or the actual publishers or the actual cloud gaming platforms, the way their relation with the networks is very limited. So the networks tend to be kind of black boxes, and at the end of the day, what they need to do is develop software and applications that can run and adapt to the network to basically minimize the network problems in the experience, in the final experience for the user. So at the end of the day, today, cloud gaming is not possible in most of the cases and in most of the countries, and it's definitely not possible to play at all time in the same way, because you are really dependent on the network status, and it's something that without doing things differently, the network is not really ready to deliver. In the future, and this is what we are working on, we believe that Telefonica and the network operators have a great opportunity because we control the delivery networks to basically plug that into the actual internet experiences so that we can basically control and give the control to the end user of the end-to-end experience. If you go to the next slide, please, Xiao. So if we were to basically look at a very high level up what this means in terms of network, basically we look at it from three very big disruptions or big differences that we need to manage and design and take into considerations very carefully within our networking architectures and specifications. The first one is basically that it is going to be a very high throughput per user streaming. So bear in mind that this is unicast streaming we are talking about. So we are going from online gaming, which is typically kilobits per second, into something that is going to grow massively, generating streaming throughputs of more than 50 megabytes per second per user. So of course, this is something really demanding from our network, and we need to be very, very advanced in order to be able to dynamically allocate resources to fulfill these services in a smart way. Okay. The second thing that is very particular and makes it really, really, really difficult and different from the other flows that we can find in our network is that it's really, really real time. So in this case, the ultra low latencies are super important, but are not the only important thing in order to have a great experience. You also need to keep the variance of those latencies, so the jitter, as close to zero as possible, and obviously minimize packet loss because otherwise the experience becomes unplayable for the final user, and you will not be able to sell your service. So in conclusion, there is a big opportunity in order to be able to deliver high performance real-time streaming applications. One of those real ones that we are seeing today is cloud gaming, and we believe also SDN could help bringing that cloud gaming closer to the end users in a more adaptive way to what it is today. Xiao is going to go now through some more detail into how this could be delivered and what the specific networking challenges are for you guys to look at. Xiao, do you want to go on?
Yeah, thank you, Cesar. So can you see me in my video, at least? So what is cloud gaming? And I think you see, from point of view of user, network is basically irrelevant. So users, the way that they interact with cloud gaming service is only this, game bot. So from point of view of users, so they want a seamless services, seamless experiences. So if a gamer is get used with controller, they will expect the same experience. So in this slide, we try to explain what cloud gaming changes in terms of the signal of gaming. I try to see what problems we're gonna have to face. So a game bot will be probably connected with a sync client, could be a laptop that I'm using to video conference. That we use about maybe some cases 8 milliseconds of latency. That signal, so the button that the user we're gonna press, we travel to the network, which has to go through the network stack inside of computer. That can take 1 millisecond, whatever millisecond can take, depending the sync client performance. That packet, in best cases, will arrive, in the cloud gaming infrastructure, which has to close the network stack. That could be 1 to 5 milliseconds, depending the virtual environment that we're using. Once the button, the press is arriving in the game logic, it has to be go through the game engine that we change the frame that will be rendered using the CPU, using GPU, according with the logic of the gaming. That rendering may take 20 or 50 milliseconds for that. So this this part of game engine and the rendering, of course, is part of consoler, traditional consoler. That at the end of the day, at the end of that render is a image which we have to code it in terms of video, which take probably 40 to 60 milliseconds depending the coder that we have in GPU. And then at the end of that process, we'll be generating a huge amount of data, which is packet, IP packet that we network guys understand, right? That we go through the network stack that we do the 1 to 5 milliseconds again. And then it finally has to travel across to our network, the network that we manage in Telefonica, and go back to the thin client, which again will be decoded, which use 2 to 4 milliseconds, and displayed, that introduce these 20 to 40 milliseconds. So basically, if we compare the consoler, which is basically the experience that customer expect from cloud gaming, that will be, we are introducing with all this network and the coding, we're introducing around 20 milliseconds of extra latency. That is huge from point of game experience. Of course, so we know everyone that if we are talking with someone, we can tolerate around 200 milliseconds. We are okay if we have to this 200 milliseconds. But for gaming, according with research, people cannot tolerate. It's basically the game become unplayable. Will be the latency that they can tolerate, the gamers, will be probably 50 milliseconds. That is a study based on years ago. Currently, probably with current game, the latency which are lower. So at the end of the day, what we want to try to explain is that in both cases, if we don't have losses inside of the network, probably we can induce as much as 30 milliseconds in round trip time inside of the network. So we have to make everything, the network that we transport IP packets, lower than 30 milliseconds. Okay, so that is just a perfect network. Perfect network. Of course, the perfect network doesn't exist. We know that the packet may losses. Of course, there are a lot of techniques to tolerate this, but in a simplest model. So if we take up account that the video is generated like 6 frames per second, it takes 60 milliseconds, 16 milliseconds to generate 1 frame to be traveled inside the network. So if some packet losses, if a 1 frame losses, we will probably take at least 30 milliseconds to realize. So of course, we can apply a lot of technique to recover that packet. But at the end of the day, if we need to recover it, it will probably generate a kind of time which we call crescent time, which is basically round trip time plus network stack time would be round trip time plus at least 10 milliseconds. So if we would do some simple math, we can realize that the maximum latency that we can tolerate for cloud gaming experience, it probably be 4 milliseconds as much if some losses happen inside the network. So this is very aligned with what Cesar commented. Cesar commented the ultra low latency, right? So latency, if we think about this is only transport network. At the end of the day, users so connect with devices. So the traffic will go through the transport network, go to the routers, home router. In all cases, we call the HMU. And we connect through Ethernet or through Wi-Fi, which we introduce extra latency, but also extra losses. So according with all labs analysis, so if we connect basically the cloud gaming solution with Ethernet, we can achieve effective throughput, which is the throughput that people see at the end of the day, 80 megabits per second. If we go to the Wi-Fi, we cannot hardly arrive 10 megabits per second. That we produce the picture that Cesar shared. Basically, unplayable user experience. So basically, but we do see a lot of opportunities in terms of network architecture, in terms of services. So here are just 4 that we share with you guys in terms of ONF, with community of ONF. I think could be relevant for ONF to define what kind of thing that we need to develop, or what kind of thing is relevant for cloud gaming-like services. First thing is edge game. So according with the analysis, so we have to deploy this game server, the server where you're running the game engine at least in metropolitan level. So it should not be longer than 3 or 4 milliseconds. That is just a mass. In other way, any kind of service won't be competitive compared with traditional console services. Another thing which I think is an opportunity, is a huge opportunity for doing resource allocation at home and edge access network. Home network in terms of Wi-Fi, we can do Wi-Fi 6, but in access network, we have been working with ONF, deep diving in capacity of Volta, for example. We can do a lot. And traditionally, resource allocation is not good. For example, for video streaming, resource allocation is not a good thing because you have to allocate, let's say, 10 megabits per second. For a video which changes resources according with the frames, it can go from 10 megabits per second to 2 megabits per second. You are losing a lot of resources if we do kind of straightforward resource allocation for traditional video services. But for gaming, it's not like that. The gaming, in order to work smoothly, it will be probably constant bit rate because you have no time to do variable bit rate coding. So it will be constant bit rate. And then, in these cases, will be not introduce any kind of losses if even we allocate in kind of part of a network to do that. But of course, we have to be dynamic. And of course, will be user-defined. So we allocate, if we can allocate resources in access network, when user start playing, that will be fantastic. That will be fantastic. And I think we make a big change in kind of providing this kind of services in access network, only in access network. Why in only access network? Because basically, for that latency requirement, probably the transport network will be not relevant. Not relevant for gaming traffic, the video traffic, but it's very relevant for multi-user gaming. Fortnite, for example. So that one thing is a cloud game, the game where you render the frames of the Fortnite. But the other piece, which is a game server, where people interact, where we can run outside of access network, the transporter, because basically gamers are around the network is not only just part of one piece of city, it's entire country, right? We have to close the transport network. In that case, the one thing that I think is relevant for transport network is relying on resilience of the data. We cannot lose packets. And we can be very efficient doing it because that traffic is very small. It's no more than 100 kilobits per second. It's very small data, which should never lose. And it should be very fast. So if you can provide a path inside the transponder, which is only used for that traffic, would be fantastic for the game experience. And the last one is that, so every piece of from application to end user, going through, all these stats, network stats, GPU, network, links, fiber, has to work together. The network has been designed currently, it's kind of black box for application. If we ask an application developer, say, give me just a tube, don't do anything. I adapt the application. The cloud game service clearly demonstrates that cannot be continued. There's no way that we can deliver a competitive gaming service with cloud gaming if application is not aware of different things network is working. And the network has to, and application and the user has to work together in a sense they can collaborate, they can change information, metric like jitter, metric like latency should be close application. So such way that all the layer, all the stacks work together and provide a competitive gaming service. So at the end of the day, of course, from end user point of view, you can do a lot of things, but end user don't only care this game part. You can do a lot, and you can explain fantastic thing for what kind of SDN that you are doing, which I'm sure is complicated. I work on that. It's complicated to explain, but user only care about game part. They don't care about network. If network, cloud gaming inside the network doesn't work better or same like console, they will never buy it. So thank you very much.
Thank you.
Thank you very much. I appreciate that. So, a couple of questions occur to me, listening to your talk and this content. So I wonder how much of your work is focused on single player versus multiplayer, and and how practical multiplayer really is, given all these tight constraints that you're describing. Have you thought about what percentage of the opportunity for you for Telefonica is multiplayer?
So please complement my personal opinion after, but in Telefonica and in general, I guess network operators, where we really are there to add value is on cloud gaming. Multiplayer gaming, so online gaming, is not so kind of dramatically different. Therefore, you don't really need to stress all the value chain until the end user so much. Therefore, really many others can do it, and they don't really need us that much to do it. But for the actual cloud gaming, the network becomes so important end to end that just by fixing everything else except the delivery network, you will not be able to deliver the experience. So for us, and this is the way we are working in Telefonica in the innovation area, it's where we are focusing is on real-time high throughput streaming for real-time communications, specifically for applications such as cloud gaming, where we believe that carriers and telcos with good networks and good future networks too can kind of untap a little bit the level field and add a little bit more value than without us.
Just try to understand more so I can give a better answer. So if you think about Mario Kart versus Fortnite, so single player and the multiplayer.
I'm sorry, was that a question to me?
Yeah.
Yeah.
So basically, I mean, from point of view network, from technical point of view, they're no different. There are no huge difference from playing Fortnite and Mario Kart. So there are two kinds of traffic. One is the traffic which is a video that we capture the logic of game and send to the network. That is a problem that we have to solve with 4 milliseconds of latency. Mm-hmm. Another traffic is game per se with the state of Fortnite, right? Where a different user interact. I think that traffic, that of course we have to guarantee the latency, of course, but the traffic per se is very small. It's 100 kilobits per second. We can do a lot to improve, latency and reliance.
Mm-hmm. Right. So that makes sense. So you're kind of separating the problem from there's kind of the single user experience is interacting with the game engine, The multi-user experience is the game engine interacting with the other game engines to share state.
Yeah, and
I guess
honestly, console has the same problem. Console, you have to interact with another console. So we're talking about competitive cloud gaming service experience, right? And so in this sense, if we're pushing the console to the cloud, doesn't lose anything. In fact, in some cases, it could be better.
Right.
In terms of that communication, right?
Right. Well, it's the game engine to game engine network and latency is better in cloud gaming because you've eliminated the home network and you're connected more directly to transport networking, right?
Yeah.
So
yeah.
Yeah. So interesting. So so given all these tight constraints and everything you've described, when do you think cloud gaming becomes practical? When's the market opportunity going to open up?
I don't share the opinion of Cesar, but let Cesar speak.
No, please, go first. I did go first before, so now it's your turn.
I think practical today is practical, right? That the problem is competitive. People don't buy cloud gaming if it is not competitive. So game is a sport. You never buy a machine that you're going to lose. So of course there are different kind of users, but for currently the high-end, high-demanding gamers, if it's not competitive, they will never buy it. That is the problem, the competitive service. Another thing is scale service. If you want to make this scale, it's not only about pushing a lot of GPU in a huge data center. It's not only that. Network is basically not prepared to absorb that constant, gigabit per second. So it's scale and competitive, I think we need to solve in the coming years. Cesar.
Yeah, I mean, I generally would agree with that opinion, Xiao. If only I would add that I guess cloud gaming as such is already happening today. So people are already using some cloud gaming platforms, and there are some cloud gaming platforms that are there already with a good level of product market fit. So basically, a good level of commercial readiness for people to start using it. But because the network is not ready in most of the countries, and because the cloud gaming market and publishers and so on is so fragmented, there is not yet a clear value propositions to really democratize cloud gaming amongst new users, right? Because people that are already using PCs and consoles, they are already playing, these kind of things, using online gaming, they are okay. They don't need cloud gaming. So when cloud gaming is really appealing for them is when they can do even more than what they can do at home. And for that, I think, the network is not there and the services are not there yet. And then for the new eyeballs, so for the new markets, clearly, there is not really a very compelling value proposition yet that can be easy enough for most of people to use it. And when there exists, it's still not great with regards to contents and so on. So there is still some time in order to be really to see real launches and really traction commercially. But I mean, I guess, Stadia and the likes are already pushing and testing the water with real commercial launches. So it's happening, and we are basically building our network at the same time in order to be able to support it when it exploits, right? Not only cloud gaming, but the other cloud gamings of the world that are coming.
Well, Cesar, you said something really important there. You said that, I think maybe it takes off when they can do something new that they can't do at home with their console or their PC. So do you have some examples of that? What are the things that are so new that will ultimately entice people to switch their mode of operating and to consume?
Well, I guess it's, we are gamers, for example, but I haven't updated my hardware in such a long time. So now if I wanted to play stuff, I couldn't. But if you are a gamer today, you would already have all the equipment. The promise that the cloud gaming is making is that you basically create an infinite, from a hardware point of view, you create an infinite platform where you can basically deploy infinite, capacity-wise applications in which, for example, instead of playing, I don't know, Fortnite, with your machine just connecting via online to a multiplayer server. Instead of doing that, you could be playing, I don't know, with your goggles from Oculus, the real French battle with the Nazis, with you know, another 100 or 1 million people at the same time, and really reproducing things that are completely impossible to imagine today, right? So it's about bringing, I mean, we are kind of envisioning that futuristic you know, platform that would be appealing for loads of people, and it will be basically like taking out the like, how do you say, the handcuffs to the actual cloud gaming, which is basically the network and the fact that I cannot do even as good as what I can do with my PC or my console. So you need to deliver first that, and then you can try to do even more. That's the theoretics of cloud, you know. So we hope that it works and it can be really great for gaming.
Mm-hmm. Very good. Good. So it's two things. It's kind of breaking away from the constraints of the console to get more compute power, to get newer, you know, we don't have an aging console, and then access, of course, to a broader spectrum of titles on demand. And so good. Well, thank you very much. I think this has been terrific. I really appreciate your time and participation in this event, and thanks again.
Thank
Bye-bye.
you. Our pleasure.
Thank you very much.